Hey, in this video, we'll be talking about compiling and linking and all of that process. So in C++, it is helpful to understand at a slightly deeper level how a program becomes a program, starting from your source code, passing through all the stages of the compiler, the IDE, whatever tools you're using, and produces an executable that you can actually run. So I'm in Visual Studio right now, and I'm looking at a Hello World program. Fairly simple, but it's going to illustrate everything we need. So first off, when you press build, so say you press the run button at top, that does an automatic build for you, or I'm going to right click on my project and I'll press rebuild, which is going to like delete some of my temporary files and regenerate them. You get to see some of the output at the bottom of this compilation process. So first of all, it tells you which file is getting compiled. It says main.cpp. That's the file in my project. So the first step, really, though, it doesn't involve compiling. In the other video, the preprocessor video, we saw that there's a step that comes first, that the preprocessor needs to come first, because your source code, as it's written, is not everything. There is other stuff, like in the IO stream header. So the preprocessor first runs through all of your code and executes these directives. So this IOStream file gets included, and any other preprocessor directives get used up. Um, Afterward, your code is going to look a little bit different. You don't get to see that most of the time, but that's what it does. Um, After the preprocessor has done its job, then your code needs to be parsed. It needs to be read line by line effectively by the compiler. So if you start at the top of your code and read line by line, you'll see what kind of errors come up if you notice anything wrong. So say I have this function, my function. Let's just call that function. Right away, before I even compile it, IntelliSense built into this IDE, built into Visual Studio, is noticing that this is going to be an error. And so if I try to build it, it gives me an error. First of all, this one with the E error code at the beginning, this is the IntelliSense error. It's telling me that this is not going to work. But the second one is my actual compiler error. The compiler is telling me that this code didn't actually work when it actually tried to build it. There are some times where IntelliSense is wrong, or where it's just stale and the information it's looking at is out of date, and where you actually have to compile it to get it to give you an error or not. In this case, there's no such thing as my function. So the compiler gave me an error saying identifier not found. There's no such thing. There is a way I can kind of get around this. I could write that function. My function, let's just make a function that does nothing. That works. I can compile that now. So there's some things going on here that happen in the parsing process, where the compiler is going through line by line, and when it sees this function being used, it needs to have already seen that function. If I take it and I move it down to the bottom, after I use it, let's try building that, it gives me that error again. So it's saying you can't call this function because it doesn't exist yet. It doesn't exist until we get down to the definition of that function. And so that parsing process is important to understand that it goes from the top to the bottom. Now, once it is compiled, then it creates what are called object files. And I'll show you what one of those looks like. If you right click on your project, go to Open Folder in File Explorer, This brings you to where your source code is. There's my main.cpp, and there's a debug folder in here that contains all of these like intermediate files that the compiler is creating. You can also go up to look at the debug folder in the solution folder, which contains the executable. So let's go back and look here. In debug, it is not in here yet. Let's try. Oh, right, it deleted it because I rebuilt. All right, let's make a successful build. Okay, and then go back to that folder. All right, so there's the object file. So the object file contains all the information that that parsing process came up with. It has to be able to make connections to all these different pieces of code, like this function call needs to refer to the actual function, and otherwise it needs to describe the rest of the code that we're using. And then it goes on to the last step, linking. Linking is when you take one or more of these object files and turn them into an executable. You link them together by connecting all these references to like functions and objects and stuff to their actual code that they're being used. Once you go through the linking process, that creates the executable. So an interesting thing we can do here is try to get a linker error instead of a IntelliSense or a compiler error. We can do that by making it so that the compiler will compile this fine, but the linker won't be able to find the definition of this. So in C++, we can use what's called a forward declaration of this function, or a function prototype, where we can take off the body of the function and just end it with a semicolon right after the signature line. And this indicates that this function exists somewhere. It does exist, or at least I'm promising I'm promising the compiler that it exists. And so I can go on and use it, but when the linker runs, it's going to have to do the work of actually finding it and hooking it up here. So it could be in a different file, it could be in a library or a header or whatever. And I'll just fake out the compiler. Okay, so it goes through the build process. It is successfully compiling, but it is failing to link. It says unresolved external symbol with this LNK error code. So it's saying that my function with all this other garbage is referenced in your main function, and it doesn't connect to anything. There's no external symbol from this file that it can actually be linked to, so it failed. So that's going to make it so it doesn't create our executable file anymore. All right, I'll go back and make this work, and then we'll build it. All right, and let's go look at that executable a little bit. Have you ever actually looked at an executable? So I can run it. All right, hello world, good. But I can also open it. Let's say right click, and I'll open it with a text editor. So, wow. All right. So that's what an executable looks like, I guess. It's got a whole bunch of these null and other things. These are just non-printing characters that this text editor will show me. It looks like a whole lot of garbage, though, all the way through. So let me try opening this in some other way. Let's go to a hex editor. So a hex editor is meant to open this kind of thing. And I can grab my executable, drop it in here. And you can see on the side, this is the numerical values of all of the stuff in the file. And then this is the ASCII values, the stuff that we can actually read. And yeah, it still looks like a whole bunch of garbage. But there is something I can find in here. Well, I just saw a piece of it. Let's see. If I scroll down here, yeah, there's some English words. My program's really simple, really small, but Visual Studio and the compiler have packed in all of this other stuff just to make it so that it can run on Windows and so that it has the proper like error handling for whatever Windows wants to do. But you can also, let's say, Control F, find hello, because I know that this was in the program, and you can find it. Cool. So there's the exact string that I put in my code, and it's still there in my executable. It is part of the like static memory that is built in and saved on your disk. So like there's got to be instructions for running my code, but there's also this memory segment where all of the strings exist and can be referenced, which is kind of neat to see. All right. So that's how compilation works and the linking process in C++. And there's a whole lot of crazy stuff you can look into. When you do this compiling and linking, ultimately the result you get is some other kind of code. It's a kind of code that your computer actually knows how to run directly. So these are machine language instructions. They can be, sometimes people talk about assembly code, assembly language, and those are specific to the processor that you're using in your computer. That's the brain of the computer, really. So it needs to understand the instructions that you're giving it. And these instruction sets are not all the same. But we've kind of standardized on a few of them that are really common. There is an instruction set that was used for a very long time, the x86 instruction set. That's actually what I'm generating here. There's also the AMD 64 instruction set that's very common for 64-bit operating systems and processors. So you can generate those as well. And another common one is ARM. The ARM platform is very commonly used for smaller devices like Android phones and stuff. Your phone has probably an ARM processor. Um, but each of those architectures has a different assembly language involved that describes the instructions that your program needs to run. All right, let's take a look at that assembly. So in Visual Studio, to see the disassembly, what this code compiles down into, we're going to have to run it through the debugger. So a way that we can get there easily is right-clicking on a line of code and doing run to cursor. But first, I just want to let me throw in some simple code. A equals, what's a good, yeah, 5 is fine. All right, and then we'll run to cursor. All right. Once it starts running to cursor, we'll get back into Visual Studio and it will be stopped on that line. Then we can go to Debug, Windows, and Disassembly. Ugh. So yeah, this is what it looks like. You can ignore the notes in here. These are just notes of what C++ code it was. But these lines are the actual assembly code. So yeah, we can see one of these. This is copying the value 5 into my A variable. Ugh. All right, I think that's enough. I don't want to look at this too much, but you can see all of the code that was generated for my program. All right, well, anyway, I hope you had fun diving into that with me, and I'll see you in the next video.